Okay, I'm going to do some practice with series circuits. I want to go through a few different examples. So there'll probably be a couple of videos here. Before we start a circuit, let's talk about the rules for series circuits real quick. So we said with our different types of circuits we're going to look at, series is the first one. There are rules pertaining to voltage, to current, and to resistance throughout our circuit. Um, Ohm's law is always going to apply. So that's one of like our first rules that we always want to think about. For a series circuit, okay, let's start with current. For current, our total current of our circuit is the same all the way through our circuit, okay? So remember when we do our circuit math, we're going to be looking at voltage, current, and resistance for each of our resistor items. Okay, so however many of those we have, usually we'll have two. You could have up to three. We won't go past that in this unit. Okay, but for each of these, they're sharing some voltage. They've got a current going across them, and they've got a resistance value. So we're gonna determine that for each of these, and then also for the total circuit. Okay. So when we talk about these rules, we're going to be applying them so that we can solve for each of our components. So like here, we've got a resistor 1, that this is going to be all of its values. We've got a resistor 2, that's going to be all of its values. And then we're going to have a total for the whole circuit. Okay, so our number of lines is going to be determined by the number of resistors that we have in the circuit. So current is going to be the same throughout the whole circuit. So my current for one resistor equals my current for another resistor equals my current for the total circuit. Okay, that should be an equals. I was thinking ahead to parallel. Anyway, let me rewrite that just so equals. So current stays the same. Voltage gets shared. So we've got a total voltage, which is the same as our voltage from our battery, and each of our resistors is going to use some of that voltage, and those are going to add up. Okay, and then resistance also adds up. So each of our resistors has a value of resistance, and each of those is going to add up to the total. Okay, so those are our rules that we want to come back to as we're going through a calculation. So let's look at, find one I want to start with. Let's look at this one first. Okay. So here we've got a series circuit. We've got a battery. We don't know the total voltage. We've got a first resistor that's 10 ohms, second resistor that's 20 ohms, and they give us the current. For series, if they give you this current, something amps, kind of in the circuit in a circle, that is your current value for your circuit. And we just said that that's going to be the same. Try and make our rules visible up here for the entire circuit. Okay. So I kind of went through some steps in how to solve these problems when we started these the other day. Your first step is always going to be fill in your givens. Okay. So we know that R1 is 10 ohms, so we can put 10 here. We know that R2 is 20 ohms, so we can put that here. We know current is 3 amps. We can put that everywhere because we know that current is the same for the whole circuit. After we do that, we look at our rules and see what can we fill in based on our rules. Okay, so we know that our resistances are going to add up. So I've got 10 plus 20. My total resistance for my circuit is going to be 30. Okay. We've already kind of used our rule on current by filling it in everywhere. The other thing we do is we look at Ohm's law. What can we fill in based on Ohm's law? Well, we see that we've got current and resistance for all of our lines, and we know that voltage equals current times resistance. So we can multiply these and fill them in for each line. So we've got 10 times 3, that's 30. We've got 20 times 3 is 60. Then there's two ways I can fill in this blank, okay? I can multiply here. 3 times 30 should give me 90. Also, I can go back to my rules. I know that my voltages are going to add up. I know that my voltage for the first resistor plus my voltage for the second resistor, in this case, because there's just two, is going to equal my total, and that will also equal my battery source. Okay, so if I multiply these, I get 90. If I add 30 and 60, I get 90. And a good thing to do when you are doing these type of calculations is to double check, because in the case of series, these should add up for voltage to the total. These should add up for resistance to the total. These should all be the same. And then Ohm's law should apply across each line. Okay. And then we can also do power. I didn't have power on here originally, but if we do power, we're just multiplying current by voltage. Remember, we just did that in the last video. So let's see, that would be 90 for this line. That would be 180 for this line. And then power also adds up, so I could either add these or I can multiply these. In either case, I'm going to get 270. Okay. Okay, so let's do another one, and then in the next video, I'll do a couple more. Let's do this one here. So in this one, we're given, I'm going to go ahead and write my givens. R1 has got 10 ohms. My total voltage from my battery is 75. And I get my current here. Nice. Okay, so 5 amps is my current, and I can fill that in for my whole circuit. This is the way series circuit works. Okay, we're going to do another type of circuit this week that is different, but in the case of series, current all stays the same. So now let's think about rules. Let's think about Ohm's law. What else can we fill in? I've got current and resistance here, so I could use Ohm's law and get voltage. So I'm going to multiply 10 times 5. That gives me 50. Let's see. I know that voltages add up. So 50 plus something has got to equal 75. So just doing math on that, this voltage value's got to be 25, because 50 plus 25 is 75. Then I've got another Ohm's law here where I can get my resistance value. Here I'm going to have to divide voltage by current. Okay, just using Ohm's law, solving for resistance. So I divide voltage by current. So I'm going to divide 25 by 5 here. And that's going to give me 5. I could do the same thing here. I could also add these up. Okay, so if I add them up, I get 15. If I divide 75 by 5, I also get 15. So there's some checks built into the way you do this. Like, now I have everything filled in. I'm going to say, does this make sense? These add up to this? Yes. These are all the same. These two add up to this value? Yep. Do these follow Ohm's law? Yes, yes, and yes. Okay. So that's just kind of a nice final check on series circuits. And then power, again, current times voltage. So let's see, this would be 250. I think that's right. I'm doing all this in my head. 25 times 5 is 125. And so then if I add these up, I get 375 for my total power. Let's see what 75 times 5 is. Hopefully it is 375. So that's a couple of examples. I'll do a couple more in the final video.